Today we are graphing piecewise functions. So here I gave you two pieces of information. I'm telling you that f of x is equal to x if x is less than or equal to 0, and f of x is equal to x plus 1 if x is greater than 0. So there's two pieces to this graph. So if I take a look at the first one, f of x is equal to x. Identify your slope, identify your y-intercept. Your slope in this case is 1 over 1. Your y-intercept is 0 because this is the same thing as writing 1x plus 0. Now, when I go to graph this, I'm going to start, and again, everybody should be writing in pencil. I'm going to start at the 0 for the y-intercept, and I'm going to go up 1 over 1, up 1 over 1 for my graph. So if I normally graphed this line, I would get a line that goes across my coordinate plane like so. However, I have restrictions with the x. They're telling me x is less than or equal to 0. So take a look at your x-axis. X is less than or equal to 0. So I have a closed circle on the 0, and it's less than, it's going to go down in quadrant number 3. So then I'm going to erase everything else because my domain is restricted. So that is the first portion of my graph. Now let me take a look at my next piece. F of x is equal to x plus 1. Again, my slope is going to be 1 over 1. My y-intercept here is at the positive 1. So again, if I went to graph this, I would have a graph that looks like this. Okay, and when I take a look at my domain, it's restricted. X is greater than 0. So x, look at your x-axis, it's greater than, it's not equal to 0. So I'm going to show an open circle on that 0, and it's greater than, it's going to go up in this direction. So I am not going to worry about anything over here. So keep in mind, you don't have to label, they're fine the way they are. I have an open circle on the second function and a closed circle on that first function. It is a function. It does pass my vertical line test. Let's try the second one. 2x plus 3. My slope is equal to 2 over 1. My y-intercept is 3. X is less than negative 1. So again, work in pencil. My y-intercept is 3. And my slope is telling me to go up 2 to the right 1. And again, just make sure you graph this backwards as well. Okay, and that's what my line would look like. However, I'm restricting the domain. X is less than negative 1. So look at your x-axis. X is less than negative 1. It cannot equal negative 1, but it is less than negative 1. So that would be my function with an open circle on the negative 1 going down. When I take a look at my next equation, 3 minus x is the same thing as negative x plus 3. My slope is going to be negative 1 over 1. My y-intercept is 3. I start at the positive 3 and I'm going down 1 to the right 1. And that would be my line. My restriction, x is greater than or equal to negative 1. So in this case, it is allowed to be a closed circle on the negative 1. Greater than or equal to, look at your x-axis. The greater thans are going to be going to the right. So therefore, that would be the graph that I would make. So I have an open circle on the first function and a closed circle on the second. Now I come to where I need to graph these. I need to write the equation of the line for these pieces. So I like to label them component A and component B, or piece A, piece B. So for A, let's take a look. Find out your slope and your y-intercept. So this is on that sheet of paper that I handed you. The graphs on that sheet of paper were a little bit better than the ones in your module. So when I take a look at graph A, I should notice that my slope is going up by 2 and running 1. So my slope is 2 over 1, or 2. My y-intercept for that first line is going to be at 4. So if I wrote this equation, I would write it as f of x is equal to 2x plus 4. Let's just stop for now, and let's take a look at b. Again, look at your slope. Your slope in this case is 0. It is a horizontal line. My y-intercept here is 4. If I wrote this equation out, I would have f of x is equal to 0x plus 4, or just f of x is equal to 4. Now, my domain is restricted. We have to pay attention to what that means. So I have two pieces to this piecewise function. For component A, my equation is 2x plus 4, such that, let's pay attention to what it means. X is going to be less than 0, such that x is less than 0. My function for the second component, b, is 4, such that x is greater than or equal to 0. Again, one of the functions needs the equal sign. It does not matter which one. It could be either one. Just know that I have a closed circle at the 4, so one of my functions equations has the equal sign on it. Let's take a look at this one. So now I have 3 components, 3 pieces, an A, a B, and a C. So when I take a look at A, I notice my slope is 0. My y-intercept, if I continued the line going all the way across the y-axis, would be at -3. So my equation would be f of x is equal to 0x minus 3, or f of x is equal to -3. When I take a look at b, my slope for b, I go up 1 to the right 1. It's 1 over 1, or 1. My y-intercept here is at 0. So f of x is going to equal 1x plus 0, or we can just write it as f of x is equal to x. When I look at c, I have my slope, again, to be 0. It's a horizontal line. And my y-intercept here, again, if that extended through the y-axis, would be a positive 4. So I have f of x is equal to 0x plus 4. Now we're going to write it as a piecewise function. So for component A, my equation f of x is -3, such that, what is the restrictions on the domain? Well, it's an open circle at the -2. So x is less than -2. For line segment B, my function is x. F of x is equal to x. And now I am going from -2 to +2 on the x-axis. So x is greater than or equal to a -2 and less than or equal to a +2. This is a comma. Okay, so I go from -2 to +2 inclusive. It includes both the -2 and the +2 because there are 2 closed circles. And when I take a look at component C, I have f of x is equal to 4. And again, my domain is restricted where x is greater than 2. And this is a function. If I take any vertical line, it will definitely pass my vertical line test because at the points that I have to be concerned about, I have an open and a closed circle. So I will definitely pass my vertical line test.